So the goal is to determine to the extent possible if the missing values are systematically missing. In other words, does the missingness predict values of the other variables? Um, and to do this, we would first have to make some determination about which of your variables that have missing data may be an issue. So that's an assessment that you could just use the frequencies in SPSS. I assume that if you go to analysis frequencies, you can run a frequency table, and the bottom part of the frequency table will give you how much missing data you have. That would be probably the most straightforward way of getting it. And so you make some determination about what variables with missing data that are an issue, and then after you make that determination, we recode, and we talked a little bit about recoding variables the other day, last week. We recode into a new variable a value of 1 if the data is missing, or a 0 if not. So we create a new column or vector of data, and that vector is going to be a 1 or a 0. It's going to be a 1 if it's missing on the variable that you determine here that you want to work with, and it's going to be a 0 if it's not missing. And so that's going to be the grouping variable or independent variable that we're going to use for our analysis. So we're taking our data, recoding one of the, or several of the, whatever your determination is here, of your variables into a new variable. And for each variable that you determine you're going to work with here, you're going to create and recode a new variable. And so if you determine that there's 3 variables that have missing data that you're nervous about, you would do this 3 different times. I always just name them missing underscore, whatever the variable name is here. But you can name it whatever you want to name it. But you have to name it something that will be meaningful for you. But that's just the way that I always do it. And so all we've done is we created a grouping variable that represents missingness for our variables that are at issue. And then we want to determine the variables in the data set that would be the most meaningful dependent variables, i.e. most likely to be related to the missingness. So they would be the dependent variables that we're going to use. And we're going to do independent sample t-test, where our grouping variable is going to be the variable, one of the variables that we just created. Our dependent variable is going to be the one that, or the variables that we think are most likely related to the missingness. And we're going to do that if our dependent variable is continuous. So if it's interval or ratio. If the variable, the dependent variable, the thing that we think we can predict with our missingness, if it's a nominal level variable, you wouldn't do a t-test because a t-test requires that the dependent variable is not interval or ratio. But if you have nominal, a dependent variable that's nominal, you're going to do a chi-square test. And SPSS makes that pretty straightforward to do. And so I say SPSS examples. And so let me, I think what I have, well, I know what I have, is I'll show you how we would do some recoding with some data that I'm working with. And by working with, it's just the example data I'm using in class, for this class. And then this sort of, once I sort of get done with that, we sort of pick up here, okay? And so this will be, I've run the t-test, I've run the chi-square. Let's delve into that and understand if the data is systematically or randomly missing. And so The data that we're working with is general social survey data, a long-standing set of data that the federal government has been involved in and academics have been involved in for really decades in collecting. Um, this data is quite wide. I guess it's not. I guess there's 53 columns or 52 columns, so I guess it's not that big. And the sample size, for whatever it's worth, is 668. And so I have a couple of variables that I want to work with. This is a income variable, so they are meaning respondent income 98, 98 meaning some variation of the way that they measure income. And so we want to dummy code that. We have some missing data, we suspect, for our income variable. And so let's see how much missing data we have, and we're going to do analyze frequencies. And then I'm going to just slide my variable over there, click OK, and it tells me that I have 421 valid cases, 247 that are missing. And then it goes into some detail here. I got 243 or 35%, 234 or 35% that are NAP or refuse, and then some people, when you ask them their income, they just don't know. And that seems like, I mean, that's not totally unreasonable for, isn't it? I mean, it could be, yeah, I mean, a senior citizen that maybe, I don't know, my mom doesn't know how much my dad is retired, but they still have income. She would be clueless, I think, but she's not clueless, right? She just doesn't know how much they make. And then, or just NA not applicable. And so we have a fair amount of missing data here, and not surprising, anybody who's collected data around income, it's a sensitive topic, and even the most carefully crafted questions, you end up with a substantial amount of missing data because it's people just with reluctance give that up. So we know that, and going back to this our steps, so that's the variable we want to work with, and then we want to dummy code this, so we have a new variable called missing income, and it's going to have 421 zeros and 247 ones, because I'm going to tell it every place that it's missing, make it 1. Every place that it's not missing, make it 0. Does that make sense? Okay. And so to do that, it's going to be transform, recode into different variable. Never use recode into same variable. Have I said that before? Okay, I'll never say it again. Recode into different variable. We can slide our income variable there. Pull this up a little bit. We need to give it a name. You can call it whatever you want to. So it's saying that we want to take our income variable and we want to put it into this missing income using this old and new value pattern. And so if the value is missing, well, let's do this. System or user missing, I think is what we have to do in this case. And let me just show you that. Sorry, we'll go back. If we go back to the data and do variable view and look at our income variable, and we see for missing that we have these user-defined missing values, but then, and there might be, well, I think that was all of the missing data if we look at the frequencies. If we look at the frequencies, yeah, everything was user-defined missing data. There was no system-defined missing data. But I could just take, if we did that, for example, And if I, here's a, this, what do we call that? What does that icon look like? That one right there? It's like your best friend in SPSS because it brings back all of the things that you've most recently did. I don't know, what would we call that? Recall icon? It doesn't look like recall to me, but just because that tells us, it lists all of the things that I've recently did. And the most recent thing I did was a frequency table that we picked. And so save you a couple menu clicks. I'm just going to rerun that. And now we have one system, we have one system missing data, that one that I deleted. Everything else is user-defined missing. And now we're going to go back to where I was before I and so I'm going to say if the old value is either user-defined or system missing data, make it 1, yes. All other values, just make it 0. Easy enough. And I could go through each of those different values that I have for the income, but why would you if you can just say else, make it 0, because that's exactly what you want it to do. And then we have this new variable that it created, and so it put that new variable at the very as the last variable in our data set. And if I do, just to make sure that we did it right, I can do analyze descriptive statistics frequencies. Get rid of this. What was the total number of missing? 248? So we should have there should be 248 ones. 248, yeah. So that looks good. 420 that not missing. So that's our grouping variable. And then the next part of that has to be, well, what do we think that predicts? What are the things that might predict in our data? And so the features that I'm using, or the variables that I'm using, it's not arbitrary or capricious, but it's not theoretically informed either. It just seems kind of interesting, so they're the ones that I picked, and they're the ones that we're going to use. We can do whether the person's male or female. And in this case, this is just a dichotomy. So we're going to do what test? So our independent variable is going to be our new dumbly coded variable.
Cross-tabulation or chi-square.
Yeah, so we just do a chi-square test because we have 2 nominal level measures, and our t-test wouldn't be appropriate. And then the other one that's sort of interesting, or not, depending on your interest, I find it somewhat interesting. There's a set of questions that the GSS ask, and the question, I don't have the wording in front of me, but the question in essence is, they ask each respondent on a range from cool to hot, cool to warm, I don't think they say hot. Cool to warm, I hope they say warm, not hot. On a range from cool to warm, how do you feel about people or individuals in these 4 different groups? And everybody gets blacks, Asians, Hispanics, and whites. And they give us a number between 1 and 9, I think. 1 meaning cool, 9 meaning warm. Okay? And so the question is do we think there's a relationship between whether somebody tells us how much money they make and how they feel about their fellow citizens, because these are all U.S. residents? We might hypothesize some there. Some of you might be thinking about how that might look. I have no idea myself. I guess I do now because I actually did the test, and so I know. But before I did the test, I didn't know. And so to do the test, it's pretty straightforward. We're just going to do analyze, and this will be the part of the video that you could go back and if you missed this part, and just figure out how to do this test. But you're going to do analyze, and we're going to do compare means. and we're going to do independent sample t-test. Independent samples meaning we have one sample that's a 0 on our grouping variable, and the other sample that's a 1 on our grouping variable. And so we're going to click that. And those are our test variables. This is our grouping variable. Seems pretty straightforward. It wants us to define our groups. In some cases, you might not have a dichotomy. In our case, it's just 0 and 1, right? In other cases, you might have 1, 2, 3, 4, 5, and you might just want to compare 1 with 2, and you just tell it do 1 with 2 or 1 with 5, and you could just make that. But you have to define groups before it will let you say, okay. I don't know that there's much with the options. We'll talk a little bit about what is list-wise deletion or exclusion later. And then we're just going to run the analysis. And then this analysis that you have here, with a few exceptions, I didn't match it up, but it should look really close to the next slide that we're going to get to here in just a minute. So we won't have to try to work our way through using SPSS. We can just use the slides. Then the other one we want to do is with whether the person identifies as male or female. And to do that, we're going to do, again, analyze. And we're going to do descriptive statistics and crosstabs. So analyze descriptive statistics and crosstabs. And you can do it either way. We could put rows and columns could be whatever your preference is. One has to be on the row, and the other one has to be on the column. But there's not a formula for that. And then for statistics, we want to tell it to do chi-square. It actually calls it Pearson's chi-square. So when you see the output, will be referenced as Pearson chi-square. Okay. And so that should be also on the slides that we looked at. Questions on what you do with SPSS to at least get some output? We haven't interpreted any of the output yet, but so the idea would be that you would take your data, create a dummy-coded or several dummy-coded variables that are ones or zeros. Does it matter the 0 or 1? Could I have done it the other way, where 1 means not missing and 0 means missing? Of course, it would be exactly the same way. But if I call it missing, for me, if I call it missing, I want 1 to be missing. If I call it not missing, that would be confusing, right? But I'd want 0 to represent that. And so, you could do the grouping. How you do it could be either way. There's no magic to that. It's just that whatever you do, when you actually start looking at your results, you need to know what you did so you know what group is missing and what group is not missing. Fair enough? Questions? How can I help? No help? And so this is a bit different than the analysis. That same variables. I guess maybe I added some extra missing data. Well, I know I added one extra missing data case, and I don't know where the rest of them went, but it's slightly different. But the logic will be exactly the same. So this first table. And one of the things, for better or for worse, SPSS, sort of the default is just to give you all output. Others, if those of you that use R, it's just the opposite. It gives you no output. You have to tell it what you want, and it only gives you what you tell it to. So it's just two different. R is sort of a minimalist. If you ever have used a Linux operating system, it's sort of that same minimalist approach where I'm not going to give you anything unless you tell me to give it to you. And if you tell me to give it to you, I'm going to give it to you, and I won't even ask. So if you say delete this column of data, it doesn't say, are you sure you want me to delete this column of data? It just deletes the column of data. And so that's the sort of other side of the minimalist approach to analysis. But SPSS is not, I wouldn't say it's minimalist. I don't know that what's the opposite of a minimalist? Yeah, SPSS is extravagant, maybe in its output that it gives us, and that I think it defaults on, it errs on the side of giving you more than you need. And part of the challenge, especially if you're new at it, is being able to say, I don't care about that, even though maybe somebody else that's doing this test cares about that. I don't care about that. I'm going to skip that, but these are the things that I care about. But I think this is pretty much the output that you would get. Of course, you're going to make sure that there's some syntax with your output, syntax that would look similar to this for the crosstabs, and syntax that would look similar to this for the recoding that I did, right? And so when you print this off, you're going to have all of that syntax, with you. So this table and this table are the two that we care about. So these are our ends for our 4 different questions. These are the means, and these are the standard deviations, and these are the standard error of the means, which is just the standard deviation divided by the square root of n, which I'm not expected to know that for this class. But if we just look at the first one, how the respondent, whoever this person is that is asking, that we're asking this question, for the 476 people who, for the 417 people, 417, who gave us their income, their average was 6.76. And those people who didn't give us their income feel slightly cooler towards that group. Yes, does that make sense? The question is the difference between 6.76 and 6.22 meaningful, or is it just, we wouldn't expect it to be exactly the same, right? Even if there's no mechanism there at all, the likelihood that we would get exactly the same mean value for those two groups it approaches 0, right? It's not 0, but it approaches 0. And so the question, and this is where the t-test is helpful, the question is 6.76 in a meaningful way, in an unlikely way, in a statistical significant way, using the vernacular that is most often used? Is it meaningful or not? And if we just look down, what's the pattern? Look down across all of those different questions. People who reported their income across all 4 questions are warmer, right? Yeah. Again, we don't know, is that a meaningful or not? And so, again, that's where the t-test is going to help. But before we can actually look at the t-test results, one of the assumptions of a t-test or an ANOVA, when we get there in a couple of weeks, is that it assumes that the data is spread out, that the standard deviation is not significantly different across your 2 groups. The mean is going to be different, but the spread of the data, the assumption of the test is that the spread of the data, that is the standard deviation of the data, is the same, or at least not, and it's probably the right, that wasn't the right choice of words, because it would never be exactly the same, but it's just not significantly different. And so when you look at the output for the t-test, these first 2 columns test equality of variances, or insert standard deviation, just square root of variance. And that's what these 2 columns test. And then based on the result of this test, we use either the row Equal variance is assumed, or equal variance is not assumed, right? And then we would read across and determine whether we reject the null or fail to reject the null. And so there's just, if these are in a meaningful way different from each other, the standard deviations, there's a correction that they can do. You pay a price for that, and the price is fewer degrees of freedom, and your level of significance is almost always going to be slightly higher. So there's a price to be paid for that, but it's really a correction that gets made, a pretty straightforward correction for our purposes, not all that, not critical at all for our understanding. The only thing that's critical is that we have to first analyze that F test, and then determine which row we're going to use, and then make a judgment about whether the means were significant or not. And so if we just look at the first row, how the respondent feels towards African Americans, the F is 6.070, and the significance is 0.014. So in that case, these are in a meaningful way different from each other. And so we would use equal variance is not assumed. If the significance level is less than 0.05, use equal variance is not assumed. If the significance level for the Levine's test of equality of variance is greater than 0.05, use equal variance is assumed. Okay? So it's that would be the logic you'd use. And so in our case, we're going to use equal variance is not assumed for the first, for how the respondent feels towards African Americans. And the t-value is 3.033. The degrees of freedom is, call it 439. And the p-value is 0.003. So we'd say p is equal to 0.003, or p is less than 0.05, or however you want to phrase that. And so what does that mean? It's significant. Then how would we interpret that first result?
The people that are cruelly towards African Americans deny answer the question.
Yeah. So our people are, and so yes, right. Does that make sense? So systematically or randomly missing data?
Systematically.
Yeah, it's systematic in that there's this. I'm not saying it's a causal mechanism. It might be causal. We don't have data to make those kinds of claims, but it certainly is correlational. And across all four questions, right? The same. We'd make the same conclusion. Yeah, I'm not sure what, I don't want to read, I don't know what that says about us as a people. I don't know. Does anybody want to take a shot at what that says about us as a people? Chris?
Not about that. I have another question.
Thank you.
I was going to ask, is there ever a time where you would ignore Levine's test from like a theoretical perspective? Let's say you had a low n, and so your standard deviations are off kilter, and so from a theoretical perspective, I can like disregard that test.
How would that be theoretical? N?
So my n is really low, and so I found this really important effect, or this effect that's present in the data. So my test is significant, but my Levine's test isn't. So
that's not theoretical. Is that what part of that is theoretical?
Because I didn't collect enough data.
I'm
not collecting all
okay.
the variance and that stuff.
Yeah. You can make the argument, right? Usually, in my experience, the difference between equal variance is assumed and not assumed is pretty minor, unless the larger the variances are, the larger that difference is going to be. And so if one case you have standard deviation is equal to 3, in another case you have standard deviation is equal to 0.5, the differences are going to be quite large. And you can make the argument and see what your peers say as they review your work, I would be personally nervous about doing that because, especially if one of them shows as being significant and the other one's not significant, and then you sort of post hoc come up with this argument as to why you can avoid the Levine's test or not have to reference the Levine's test. That would feel, I don't know, creepy isn't the right word, but what would it be?
Dirty.
Huh?
A little dirty, right?
A little dirty, yeah. You're cooking the books there or something, right? I don't know what the right, but it just doesn't feel right to me. And so, but there might be instances, and again, it's not there's just not a lot of black and whites you're going to get from me. And if you can make the argument, and your colleagues say, yep, that makes lots of sense, Chris, then you're golden. And then hopefully if somebody replicates your research, 3 months later, they find the same thing, right? Or if you replicate it, you find the same thing.
So your other option would be to transform the data in some way, right? To maybe make the standard deviation.
Yeah, there might be 2 outliers that are causing your standard deviation in the one group to be so crazy high, right? It could be if I'm with a bunch of undergraduates and we're just doing age, and we have 2 groups and I'm in one of the groups, I'm gonna, assuming the N is fairly small, I'm going to move that standard deviation high.
I'm just which would be the harder sell, right? This theoretical argument I'm trying to make about why it is, or I transform this data, and a lot of folks seem to.
For me, I would buy the transformed argument. That would be just me, though. Others might. But by theoretical, you mean theoretical.
Yeah, right.
If it's not theoretical, but theoretical, then that would be something different, where there's something about your theory that you're working with that suggests that there should be larger differences with this one condition or this one group, then that would be I think a more persuasive argument than a transforming the data. Other questions that I can give really long, convoluted, wandering argument or answers to? So everybody understands what you'd do with your data. You're going to dummy code up a couple independent variables. You're going to sort of think about what dependent variables you should be using. Do some t-tests. Those of you that have to randomly delete some data, what do you expect you'll find here? If you just go through and delete every 5th person, it should not be significant unless you just have a bad, every 5th in some way systematically, right? So if you're deleting people, I'd be shocked if you found significant results. But it's not impossible, right? It could theoretically, it could happen. Any other questions here? So then the only other piece is we ran this chi-square test, and we see our Pearson chi-square with the chi-square value is 8.36. Degree of freedom is equal to 1 because it's just 2 by 2. And it's 0.067. How do we interpret that? The P is 0.067. Significant or not? What would be our critical? 0.05? So we're 1.7, well, we're slightly above that 0.5. Would you be comfortable in saying that this is randomly missing data? I don't think I would be either. I think if the reverse, if this was a hypothesis that you were testing, you probably would try to less than 0.1, right, or something. You might try to, but so I would feel. I think dirty is too strong of a word. Creepy is not the right word. I'm trying to think of what is it? Sketchy. Sketchy. Yeah, it's sort of sketchy. I'd feel a little sketchy if I was making those kinds of judgments with my data. But if we look at what's going on, and this is how I would read this table. So the percentages sum across the rows, right, to 100%. So I would read down, right? So if there's something this way, I would read down. If there was something the other way, I'd read across. That's just, I don't know where I got that, but that's just, it seems to make sense in most every case, and it certainly does in this case. So if we just look at missing income is 1, 33% of males didn't give us their income, and 40% of the females didn't give us their income. So in terms of percentages, females were more likely to not give us income, right? And then I would say that data is, at best approaching systematic missing data, or you might just call it that, because it does seem to be fairly, 7% or nearly 7% seems to be a fairly substantial percent, at least the way that I'm thinking about it. Other questions?
So if I'm not significant for my Pearson's chi-square, but just looking at my cross-tabulation, I could make a case for. Or
If it's not significant, you well.
And or the other way around. I could use my cross-tabulation to make a little bit more.
But the chi-square test is testing the percentages, really. It's testing.
In an approaching scenario, I could argue either.
You have the latitude to argue either, and you have that power and that responsibility to do what isn't sketchy for you, right? All right. Other comments, questions? So we'll talk a little bit about, and we'll probably. I don't know that I'm going to power through the rest of these, but we'll get through enough of these where you'll be able to do, let's just make this, you're going to be able to do for Wednesday at the start of class in the Dropbox have number 2 and number 1A and number 1B, okay? And then C and D we're going to start with next week, and those will be due the week after. And does somebody have the schedule handy? There's not another. Am I giving you another homework? Okay. And if there was, I would push that one probably to next week, or we would manage that together. So I want to just we'll get through as much of this as we can, but I think you have everything you need in order to get this. 1A, B, and 2. Yes, thank you. So, if you find that the data, there's no significant relationships between, you didn't identify any significant relationships here, you didn't identify any significant relationships here, we would say that the data is missing completely at random, and the normal approach would be to use what we call list-wise deletion. And list-wise deletion is the SPSS default. And so if somebody says they just use SPSS to take care of the missing data, this is what they did, is list-wise deletion. And what it does, it excludes any case, any row of data, that is. It excludes any case or row of data, same thing, from the analysis if it has missing data on any of the measures used in a particular analysis. And so if you're not using some of your columns of data in a particular analysis, it's completely ignored by this. Those columns of data that you're using in an analysis, wherever it sees missing data, system missing or user-defined missing, it just removes that row of data or that case of data from the analysis. And so if you have 30 missing across several different variables, your n is going to be n minus 30 for the analysis, okay? And that is, again, it's the best case scenario. we just think of the new sample because we actually have a new sample that our analysis was run on, right? It's not run on our complete sample. It's run on the complete sample minus the missing data, whatever that amount is. And the new sample is considered to be a random subsample of the original sample. And so we can never be positive that it's a random subsample because we only tested, some small selection of variables. But given what we know and what you have for data, this is probably the best outcome you can hope for with missing data. Pairwise deletion is another approach. I wouldn't ever recommend it. It's a little box you can check in SPSS, and some people just, we're sort of data mining, and I just want to see if I can get some significant results, and that box looks like I can easily check that. Bad idea if you don't know what it does. What it does do is it builds a correlation matrix with the data that you do have, but it's a pairwise correlation matrix. It doesn't look at all of your data. It's only looking at the data in a pairwise fashion. And in many cases, or in some cases, you can get correlations that are really theoretically or mathematically, might be a better way to think about it, mathematically impossible to get given the actual correlations that you have with your data. And in your textbook, at least in the version of the textbook that I have, they spend a fair amount of time and give you a formula that's about as long as your arm on how you can calculate that outer range value. Not particularly important for us. The part that is important for us is don't choose this option. Okay? Don't choose, if your advisor says do pairwise deletion, send me an email, and I'll send your advisor an email and tell them that they're wrong. No, I just have never seen. It's not good practice. It might make you feel better because your N is going to be larger, right? Because if you have 30 cases or 30 rows of data with missing data, if you do pairwise deletion, in all likelihood you're not going to lose any of that data, but the analysis could be completely garbage. And so, word warning. If the sample has systematically missing data, in terms of a remedy, so in our case, we found significant t-tests and at least approaching significant chi-squares. So we have systematically missing data. Can the culprit variables be excluded from the analysis? So maybe if I just decide I'm not going to use income in my analysis, is that a possibility? I assume you collected it for a reason, so it probably isn't, but it might be. And so that would be that might be an option. If that's not the case, then the nature of the missing data needs to be disclosed in the manuscript, along with what the potential implications might be. And then you're just going to use listwise deletion anyway. It'll listwise delete out those cases that are missing. So far, so good. I wonder if so here's I just want to make sure that I had that up there. 5:50. So we have another 6 minutes. Is that right? Yeah. Okay, we're good. So there's a lot of software and a lot of professionals have done a lot of thinking about what do we do with missing data. And there's some, we call them imputation methods, where we impute missing data, that is make up values for missing data. Sometimes what we might do is just use the mean, right? So let's say our income variable that we had, where we were missing 240, whatever it was. Some people might say, well, let's just take the mean income and give everybody that didn't give us an income, just set them at the mean. I don't know. There probably could be worse solutions. I don't know what it would be, but some people do that. That's probably one. Go ahead and make that argument if you think that that's the best way. I think SPSS actually has impute missing data, and that's how it imputes missing data. It just takes the mean. There's some other more sophisticated algorithms that look at, it tries to identify, the algorithm identifies other cases that are similar to the cases with the missing data, that have no missing data, and it matches as closely as it can, and then it gives the missing data value that matches closest to the missing data. And so it's a fairly sophisticated algorithm. I think you have to pay a couple $1,000s for it in SPSS.
Okay.
R statistics, those of you that program in R, it's free, and it does it equally as well. So another reason why you should become programmers and learn how to write R code. And by the way, I teach undergraduate statistics, and I make them learn how to program in R. And it's not, and they can do this by the end of the term, I think. They can certainly do very basic things, including bringing in data, and so it's not some weekend when you have nothing better to do, download a free copy of R, find some YouTube videos, and what more fun could you have, right? A couple cups of coffee, and you're good to go. And so these imputation methods really should only apply if your data is missing completely at random, or missing at random meaning the independence variables in your data help predict the missingness. I don't see it done in communication literature that much. I'm sure we could find some examples of it. Somebody could do a LexisNexis search or something. We'd find some examples where people did it. But you just don't see it that often. So that's probably, if you did decide to do this, that would sort of be, you'd have to get over that hurdle of a reviewer who's never seen this before, or a committee member who's never seen this before, and they think you're cooking the books and making up values. And so it's probably not worth, in a lot of cases, not worth the price you'd have to pay. And so reporting, I guess if you have no missing data, I would like to know that, and just make that, especially if it's a multi-phase study. So I did time 1, time 2, time 3, and at time 3 I had 100% of the people that I had at time 1. Tell me that. Just don't make me look at your F test to see what the degrees of freedom are for time 1 and time 3. Just tell me that you did a really good job of getting your participants back. If you have missing data, you should report. If the missingness is missing completely at random or otherwise, report your solution. You use listwise deletion. I assume is probably what you're going to do. And then I think this is the write-up that you're going to make, that you can sort of use, not as a template, but as logic to think about how you'd write up a paragraph for your data. Questions? Slides? More lights?
Just in the replacement strategies, one of the things, I guess Sebastian and Fidel were saying, like the mean substitution is more conservative than sort of guessing. But if I have enough information, if I'm able to look at, let's say I've collected address or locality or education, isn't guessing more conservative? Because I'm sort of looking
Conservative meaning what in this case? Meaning
it's a more educated guess than putting the mean. I'm guessing they mean like statistical conservativeness, like trying as much as possible to retain the variance.
Yeah, and so I think, if you have that kind of detailed information, so like one of the things that I do a lot is we might have an ACT score for a student, but we don't have any high school GPA for the student. We can put ACT scores we can use ACT to pretty accurately predict high school GPA. So that would be using that logic would be more conservative than using the mean. I think I'd call it more conservative. It certainly would be a smarter way to do it, whether it's conservative or liberal and that. But it'd be conservative in that it seems like it's gonna be I don't know. It, just putting the mean value in seems like I don't know, crazy. It doesn't seem that there's not a lot of logic there, other than well, that's the center point, so let's just use that. And anything that uses more data, it just seems to me would be.
Sometimes the mean itself is meaningless.
Right, yeah. Questions? Everybody knows what they have to do next week? I look forward to seeing you between now and then, if you have questions. And I'll see you next week. If not, thank you. I would have totally forgot.
I just like bossing people around.
I like being bossed around when it comes to this.